Today we're going to be looking at solving equations by elimination. First, we're going to solve the system of equations. We're given two equations, 2x plus y equals 5 and x minus y equals a negative 2. So we simply add both equations and we find that 2x plus x is 3x and plus y minus y, the y goes away. 5 minus 2, of course, is 3. But we don't want 3x, we want x, so we divide both sides by 3 to find that x equals 1. Once we've found x equals 1, we can use either equation to solve for y. I chose the top one here, 2x plus y equals 5. I plugged 1 in for x, and I got 2 plus y equals 5. Subtracting 2 to both sides, we found y equals 3. So then the point 1, 3, is a solution to this system of equations. Continuing on with the idea of solving systems of equations by elimination, we have two equations. One is x minus 3y equals 6, and the other one is 2x plus y equals 5. We multiply the second equation by 3, and when we do that, 3 times 2x is 6x, and 3 times y is 3y, and 3 times 5 is 15. Looking at our first equation and bringing it down here, we decide that we're going to add these two, and when we do that, 6x plus x is 7x, 3y minus 3y, the y's go away, 15 plus 6 is 21. But we don't want 7x, so we divide both sides by 7 to find x equaling 3. Once we know x, we can use either equation to solve for y. I chose to use the second one, 2x plus y equals 5. Putting 3 in there for x, we know 2 times 3 is 6. When we subtract 6 to both sides, we end up with y equaling a negative 1. So then the point 3, negative 1, is a solution to that system of equations. Moving on to our next system of equations, we have 8x plus 2y equals 4, and 4x minus 2 equals a negative 2. If we multiply the second equation by negative 2, we find that a negative 2 times a negative 4 is a positive 8x. A negative 2 times a negative 1y is a positive 2y. And then negative 2 times a negative 2 is 4. And that equation is equal to the first equation. Then when we find both of the equations equal, then the system has an infinite number of solutions because they are the same line. Now we have a fraction in our system of equations. The first one has 2x plus y divided by 3 equals 4. So we'll take that times 3 to get rid of the denominator of 3. And when we do that, we get 3 times 2x is 6x. 3 times y over 3 is simply y. And 3 times 4, of course, is 12. Taking 10 times the second equation, again trying to get rid of these denominators, the least common denominator for 2 and 5 is 10. So we take 10 times the x over 2 to find that that's equal to 5x. And 10 times a negative y divided by 5 is simply 2y. Now that equals 10. So we have one equation here and another one here without fractions. Continuing on with our problem, we have those two equations, and we're going to take 2 times this first equation, and we find that that's 12x, taking 2 times that 6x, and then taking 2 times the y, we find that that is 2y, and then finally 2 times 12, which is 24. When we take that equation and add it to the second equation, which I rewrote here, so we have this equation and this equation. When we do that, we end up getting 17x plus 2y minus 2y, the y's go away, and 24 plus 10 is 34. But once again, we do not want 17x, so we divide both sides by 17, and we find that x is equal to 2. Now we need to solve for y, and I chose to use the equation 6x plus y equals 12. Once again, you can choose any of those equations to work with. But when I plugged in 2 for x, I found that 12 plus y equals 12. Well, subtracting 12 to both sides, y ends up being 0. So then our point is 2, 0, and that is a solution to our system of equations.